Hello everyone and welcome back to FOSS, our course on open source and the software industry. Starting out, we will now take a look at open source in general. I will provide a short overview of its many aspects and dig a little into its history to understand and lay the groundwork for the later chapters, later lectures on the various individual aspects of open source software and the industry. You may already have noticed the use of the term FOSS, or sometimes also FOSS, or simply open source software. This is a historical term in that there was at some point of time a struggle over what exactly is open source software. We will see there are those who talk about free software, those with a Hispanic or Spanish context added the libre to differentiate free, libre more clearly from open source software. We will see that while there are small differences in what that actually means with respect to the freedom or openness of software, today it doesn't quite matter as much. I've chosen here to use the inclusive term, including everything, the free people, the libre people, and the open source people. And in general, there are no major remaining discrepancies. Open source software, whether free, libre, or just open source software, comes in many forms, many projects. There are a gazillion projects out there now, many just not relevant to anyone but the original creator perhaps. But many of these projects are actually of economic significance. And that's probably the projects you may know about mostly. So here are a couple of examples. Today, perhaps OpenStack is the most visible one because of speed of development. Underlying it is, of course, Linux, since open, etc. But the Apache projects like the Apache web server may well be known, the Debian Linux distribution, Python as a programming language, the Eclipse programming environment, IDE, that you've probably been using in your courses, and on and on and on. Here you can see how, even if you don't quite know each logo, open source is very broad. It ranges from infrastructure all the way to applications like OpenOffice or Sugar CRM. In general, though, open source, people always believe that open source plays at the infrastructure level. A more precise wording would be open source works really well for not competitively differentiating software, which is to say, if there is not a lot of money to be made, then people are more willing and more likely to share. That's not necessarily infrastructure, but often it is infrastructure components embedded in commercial products. In any case, open source is very broad, and there's probably by now an open source project for every need out there. As mentioned earlier, there are really two ways, complementary but not contradictory ways of looking at what open source software is. There's the legal definition, where you talk about the rights that are given to you when you receive open source software, and also sometimes the obligations that are put on you if you are using open source software. In parallel to these license aspects or legal aspects, there's a process definition of open source which involves the openness of the development process, how you may participate, how this process plays out, and who else might participate. So let's look at that in a little bit more detail. The initially mentioned free software is software. So free software is just software. It becomes free software if it fulfills the 4 freedoms as defined by Richard Stallman, to be discussed later, meaning you as the user receive with the software the rights to use, study, modify, and distribute the software free of charge, or any other restrictions. It's been popularly coined using the phrase, we are talking about free as in freedom to do things and not as in free beer, meaning free of charge only. So it's a freedom actually of the software, as we will see by way of the so-called copyleft license category. It's a freedom of software, not so much of people. Free software certainly comes with obligations to fulfill, as we will see. Then there is, of course, open source software, very close to free software. And open source software is software which, formally speaking, fulfills the 10 requirements for open source software as laid out by the Open Source Initiative, linked to here. And if a software license for software fulfills these requirements and the license has been approved by the Open Source Initiative, then we can say the software under such an open source license is a proper open source software. Open source software came after free software, and it's partly a reaction to that. It's partly a reaction because the free software movement was very adamant, very clear about the needs to not lock in any software, wanting or asking that all software be free, hence freedom of software. And that was just way too much for some people. Mostly because it quickly or over time took on some sort of political overtone, which made more rational people looking at software from an economic perspective, wonder what this is and often discount the free software movement as some sort of communism, which it may or may not be. But the point is, for open source software people, it's just a way of developing better software, and it's not about making a political statement. Hence, in reaction to free software and some of the verbiage that came with it, the Open Source Initiative was created, led to this new definition of open source software and the introduction of this term, open source software. But this is all 20 years ago, and today open source and free software are largely compatible. In fact, you can find on the websites that the licenses that are considered free software licenses and open source licenses are usually compatible and address the same software. Next to these legal aspects, as mentioned, there's a process aspect to open source software, and we find it on the Open Source Initiative's website, spelled out quite nicely, like here. Open source is also a development method for software that harnesses the power of distributed peer review and transparency of process. So open source software development as a process is a distributed one based on peer review for quality assurance, and that is transparent to anyone who comes looking. From that follow some benefits, which are better quality, higher reliability, more flexibility, lower cost, and above all, an end to predatory vendor lock-in. So there is actually here a political statement in that vendor lock-in, meaning you can only go to one vendor because by way of a closed source license, they only give you closed source, and hence you cannot do what you want along the lines of, for example, the four freedoms or the openness of open source licenses. And that is considered or sometimes placed out in a predatory way. So yes, there is also a political aspect to open source software. The difference between an open process and a closed process perhaps was best described, or not best, but initially described by Raymond, using a favorite or famous by now comparison between what he believed were two styles of building buildings or building ecosystems, if you will. He tried to liken the development of closed source software to the building of a cathedral and the building of open source software to the collaboration in a bazaar. So when you build a cathedral, according to Raymond, it's carefully crafted work led by a master designer, etc., etc., while the bazaar is just to the onlooking eye, maybe uncoordinated process of various agendas, people performing work, perhaps contradicting each other, but ultimately functioning. Whether this is a good metaphor, I don't know. It does not appear to be one to my eye, but it is quite a famous description of how open source processes may be understood as being different from closed source processes. At least it may have been true 20 years ago. Today, where we have a lot of open source processes play out inside companies, it's probably not true any longer. Nevertheless, this particular paper about the bazaar of open source software development gave us several memorable sayings or slogans, either by Raymond himself or being picked up and reflected by Raymond. For example, that given enough eyeballs, all bugs are shallow. By open sourcing, you get your software to as many people as you can, and because of the high use, then, or the assumed high use, you will be able to uncover bugs more quickly, with the benefit of maturing the software more quickly. As a consequence also, you should release your software early and often in order to gather that feedback and not work behind closed doors. A better way, if you ask me, is the Apache way, which is a label for the way how the Apache Software Foundation, a non-profit organization that is the host for the Apache software projects and the Apache software license, how the Apache Software Foundation views its processes. So the Apache way is mostly based on the principle of meritocracy, government by merit, and it grew out of the original Apache software project, the founding project, if you will, which is the well-known Apache web server. Today, the Apache Software Foundation, of course, is host to a large number of economically important open source projects. The Apache way codified the way how the members of the development team behind the Apache web server collaborated. And it was a peer-based, peers among equal way of honoring each other's contributions, constructive feedback, and making of decisions based on the merits of the argument rather than the particular status or reputation that a person had. It led to the creation of the open source foundation called the One Open Source Foundation, again the Apache Software Foundation, a career ladder, and on and on and on. A lot of innovations came out of the Apache Software Foundation, the, in my opinion, gold standard for open source foundations, and we will revisit this again. So my take on the open process of open source is codified here or described here as open collaboration. We studied many different open source software projects and tried to understand what is common to them. We quickly found that there is no single open source software development process. It's not possible to come up with one unified description of open source processes that you could then enact as you might create a new project. Rather, what we found was common to these open source projects was a particular set of principles that guided the development. One key principle is the meritocracy principle that the Apache way already codified. If you will, we simply split this one up and made it more precise by finding 3 principles by how people collaborate in open source projects. More specifically, Open source projects are egalitarian, meaning you don't exclude people. You're open for contribution. Everyone can contribute. You don't make a distinction between who's in, who's out forever, but rather it's possible to join and be recognized for that. It's a meritocratic process in that decisions are based on the merits of the argument. So it's the quality of the argument, the technical content that counts, and not the status or reputation of the person saying something. And finally, open source processes are self-organizing in that the process is adapted to the peculiarities of the involved people rather than people having to follow a single predefined process. That's not to say that you randomly change the processes. After all, if someone joins a project, there is a pre-existing process. But it does mean that you're trying to get the most out of people. Compare that with classic traditional work inside companies, which is hierarchical. You get assigned to a project. You cannot just join or try join a project. You may not even know about a project inside a company. Also, inside companies, decisions are status-based. Ultimately, there's a CTO or CEO who can cast the decision, and it's a take it or leave it for the rest of the people, and not the meritocratic way of open source projects. Finally, companies typically want you to be replaceable, meaning they have a process and you need to conform to that process rather than that you adapt the process to your project needs. Here you can see one result of our open source research. It's an unproven, unvalidated, yet hypothesis, but it's quite an interesting one because it shows how open source software development processes might be very different from traditional closed source software processes. Now what you can see here is a measurement we took. It's a bit older by now and the data is a bit fuzzy, so really this is only a hypothesis and not some validated truth. And what you can see is the size of open source projects measured by number of core developers and how many of that size existed for a given year. So each line is 1 year, and you can see how 1995 is the lowest year line here, and you can see that there were 10 to the power of 0 size, meaning one-person projects, and there were 10 one-person projects in our database. Of course, there were more, but our database, which is representative, but had for that year only 10 projects of size 1. But there were already about 4 projects of size 10 committers. And then you can see how year after year new projects were started and projects grew in size. The final data points we have here for 2008 show, for example, that there were 10 projects of size 1,000 developers or more. That's a large project. Companies who would create projects of 1,000 developers would be taking high risks to do that. If anything, it develops incrementally. But open source, this supposedly, in the eyes of some, uncoordinated, unprofessional type of software development, was actually able to create and sustain projects of this size. At the same time, you can see how in 2008 there were about 4,000, 5,000 projects of size 1 developer, core developer, in our database. And the interesting thing from a hypothesis perspective here is that there seems to be a steady, constant growth of open source. Basically the gradient over these year lines, which suggests the hypothesis that open source software development processes are scale-free. It doesn't matter how big they are, they just work equally well, whether they are small or large. And that is a super interesting hypothesis. We still need to get better data and do the math, but it would be quite an upset if we were able to show that empirically, because it's certainly not true for closed source software development. So if we were to prove this, open source software would be the development processes of open source software would have been shown to be superior to closed source software development processes. And the processes, so we have this duality of the legal definition and the process definition of open source software. And as you can see here, we can further divide this where the license is open and closed and the process is open and closed, and it leads to these 4 types of projects you can have. An open license means it's legally speaking open source software, but you might have a closed process with an open license. For example, the database company MySQL, now owned by Oracle, has a closed process and still makes the software available for free under an open source license, or used to. And on the other extreme, you could have an open process where people can join and contribute, but the license is closed, meaning you have to pay and don't get the freedoms or certain usage rights as long as you keep paying. And so you can see how basically we get to a 2x2 matrix of 4 variations, and then of course there will be more hybrid solutions later on. So we have a design space, a possibility space for what is open, what is closed, and everything in between. Here is another fun result from our research. I hope I can motivate you to get into open source research. And it shows when people perform work in open source. Now, open source software for 10 years or longer now has been super fun for software engineering researchers, because for the first time we could get to all that engineering data. See, in the past, if you wanted to analyze empirically by data software engineering processes, you would have to talk to a company, and then you might be lucky and get that data, but all you had then was data on one company. So you could not claim, for example, that the way SAP worked, Microsoft would work. So generalization is hard if you only have one company and you want to talk about other companies. Now, with open source, all the data is on the web. Everything's public. You can download the behavioral data of software developers from GitHub and other source code repositories and websites, and analyze it for whatever your research question might be. Here you can see the results of one such piece of work. We looked at when do people work in open source. So you can see 7 lines here, each for 1 day of the week. The dashed ones are the weekend days, Saturday and Sunday, and the non-dashed solid ones are the work days. And we aligned them over a norm day, meaning people in different time zones, when they worked, were shifted such that they all fit onto this norm day of 24 hours. The measurement here is when did people make a code contribution to a repository, so it's the timestamp of the commit that we took as the data point for when did people perform work. So usually it's they performed work and committed at the end, so we are looking at the end of it and the work was leading up to that commit. Our database delivered this data that people were somewhat busy at night with a low point in the early morning hours, 3, 4, 5, 6 a.m. Then in the mornings, starting 9 a.m., work would pick up rapidly. There would be a lunch break, another peak after lunch, a drop-off for dinner, and some restarting of work after dinner. So it's interesting. There are actually 3 different groups in this data. There are people who just worked from 9 to 5 and no work in the evenings. There were enthusiasts who only worked on the weekends, and there were those who worked all the time. Now, what is perhaps surprising, or should be surprising if you happen to not believe that open source is something professional, it's that most of the work, you can see here, is performed Monday to Friday, 9 a.m. to 5 p.m. after aligning for time zones, etc. Most of the world work considers this work days, and the software of the world, open source software, is not developed by students who might not be in class but rather be hacking away. No, so these are obviously professional software developers who have a family perhaps, and they are paid for it. So the interesting insight is that this just looks like regular software development work. Well, there are the outliers in the evenings, on the weekend. Again, there are 3 types of developers in here. But what this graph shows us is that open source software development has arrived in the mainstream, and that people are simply performing open source software development as part of their day-to-day work as employees of some companies. It's not only us who found that. Many other studies have been done. Perhaps of most interest is the Linux kernel here, where one other very conservative as well estimation showed that at least 65% of the code that went into one recent new code that went into one recent kernel release was created by companies working for by people working for companies. So again, it is companies who pay their employees to write open source software code, to which they then give away for free to the rest of the world. From an economic perspective, a very surprising result, because why would these companies be spending money to develop some software that then their competitors could also benefit from, because open source licensees give their competitors these rights? Well, that's part of the second half of this course, where we look at the underlying business models of open source software. A final data point of why open source software is here to stay. Using our database back then, we looked at the growth trajectory of open source software and found that the best closed analytical model for the growth of open source software that we could find was actually an exponential growth model. You can read it in the paper mentioned in the title. And of course, it will not continue forever with exponential growth, simply because the resources of production, meaning the number of software developers in this world, is limited. But for now, for the longest time, open source software development has been growing exponentially. And it remains an unanswered question of where it might come in from the time spent on software development in total. Some may argue that all software development will eventually be open source software development, so 100% of development time will go into open source software. Probably not, but it would be quite a difference if it was 80 or 90% versus 5 or 10%, as some might think. My best guess is something like 70–80%. Also, that's how open source software may end up. Maybe it's less. There's also a difference to be considered between the amount of usage and the actual development time, of course. Well, that already made clear that if there's such an investment, there probably is a lot of use of open source software in the industry, in commercial products, or at enterprises. And various surveys found exactly that. Companies, enterprises are no longer shy of using open source software in the data centers. Companies are no longer shy of embedding open source software components as part of their products. And as a consequence, money made on open source software components and products has been growing steadily and strongly actually it's a viable approach to business, generating significant revenues. And again, something we will look at during the business model part of this course. Here is scribbling from someone at Huawei, Chinese software and hardware manufacturer, who had in 2016 had about 200 open source software developers they employed and deployed with a strong focus on OpenStack. And interestingly enough, that made them late to the game. So they were actually struggling to get a foothold in the OpenStack software for cloud computing. We will look at why they did this and how this was important to them later on as well. But they estimated that in their products, ultimately, of the code doing its job in their products, the routers, the cell phones, what have you, at least 80% of the code would be open source code. So you look at a router by Huawei and you'll find that either now or in the future, it would stabilize that around 80% of the code there was shared and developed jointly with other companies. Meaning that the remaining 20%, of course, are the more important because that's the closed source part. That's where the competitive differentiation between Huawei and other router companies is happening, in addition to the hardware properties. So with companies engaging with open source, because that's what's making it sustainable beyond the volunteering and fun aspect, we will have to look at, or people need to look at, how companies do exactly that. The first step, as you can always see, is to use the software. A second step, usually taken in that order, is to opportunistically contribute to software. Because, for example, the components you're using contain some bugs. You found those bugs, you fixed those bugs. Now you need to catch up on a new component version. You don't want to have to reapply your patch, your bug fix again and again. Rather, you'd want to get your bug fix into the main line of the open source project and be done with it once. So after use and contribute, then you might want to create and lead open source software projects. And we will look at that as well. So here you can see how venture capital relates to open source software. And we can see that the investment of venture capitalists who very clearly have a perspective on why they're doing it, which is to create a return for their investors, look at open source and they are seriously investing in companies which have an aspect or a fully open source based business model. So as the author of this cited report here says, it's not just software in general that is eating the world, but rather it is open source software that is eating the world. Paraphrasing Mark Andreessen's famous saying. In addition to all this economic progress, we can also look at what it means for software developers to engage with open source projects. Here is a quote from one such study we performed, where we talked to venture capitalists and asked how they evaluate startups. And the surprising insight, as one aspect of our study, was that venture capitalists would look at the resumes of the developers of a startup, which usually has a small number of people, and based on the open source portfolio and the position of people, they would adjust their valuation, meaning how much money they thought the startup was worth, as part of the calculation on how and how much to invest. And they would thereby give developers an important negotiation point as part of being a founding team or early employees of a startup. All right, so let's look at the history, or a very short abbreviated history of open source after discussing the economic significance or various aspects of the economic significance of open source software. So in this short history, we are reminded that computer science and the software industry isn't actually comparison that old. Software only came into its own maybe in the 60s, 70s perhaps. It took a while to separate itself from the hardware and be recognized as its own intellectual property product. And during those days, software, because it did not have its own reputation, was shared freely. So when people recognized that software could be separated from hardware and could be its own product, it became closed source software because it was not shared freely any longer. And this upset a person called Richard Stallman, the creator of GNU Emacs and the initiator of the Free Software Foundation. It led to one of the inventions of that open source software has brought us, or free software has brought us in this case, which is the set of copyleft licenses, most notably the GNU public license. With it came also that aforementioned rhetoric on software having to be free, etc., upsetting a fair number of people. So in the 90s, pragmatism came back and led to the creation of the Open Source Software Foundation with a focus of the openness and not so much on freedom. And with it came in the 90s an increasing number and until today continued explosion of the number of open source software. I argue that during the 2000s until 2010, professionalization of open source took place, but really it's been continuing. Growth remains probably exponential, professionalization keeps going on, etc. We clearly understand now the business models that have made open source sustainable and why it's not just some hobbyists pulling the cart, but rather why it's companies who have made open source this sustainable phenomenon. I mentioned how some companies are really at the forefront of this, and still in my daily work as a professor talking to companies, I learned that many companies have basically no understanding or very little understanding of open source software. So in a way, this quote, which I believe comes from William Gibson, applies. The future is already here, it's just not evenly distributed yet. Meaning some understand very well what is going on and others remain unaware of it. This will naturally change, but the knowledge at least is already here. When you look at the open source history and its evolution, you can see these different models, if you will, types of projects actually, and accompanying business models that have made it sustainable. There are the original community open source projects. A project developed in an open process under an open source license using a community of developers, and you can find Linux there, of course, and you can find in that band here at the bottom foundations that support such community open source projects. Still, quite early, if you will, here 1992, 1994, SUSE, respectively Red Hat, as commercial companies were founded, and these so-called software distributor firms, open source distributor firms, earned a nice living by repackaging and by packaging and quality assuring, in this case, the Linux operating system. So for the first time, the first companies here as a classic product had the open source distribution that they provided as a product to companies. I'm ignoring Sigwin here, which is another case, but we will come to that later. After the open source distributor firms came another business model, a non-profit model in this case, which were the developer foundations. So the Apache Software Foundation and the precursor to the Linux Foundation, OSDL, they showed up at the end of the last century, and ever since we've seen a stream of developer foundations where software vendors jointly develop open source software under defined circumstances that they all benefit from. So this has given us the Apache software projects, the Eclipse software projects, all things Linux, etc. In parallel, yet another open source business model, for-profit business model, developed, what I call the single vendor commercial open source firm or business model, and it is companies who have an openly licensed product with a closed process, meaning that if anyone wants to use the software commercially, they could do so under the open source license, but maybe that wasn't enough. They would rather switch to the commercial license because they could only go to this one company to rely on services and support. It's a well-worn business model by now. We will look at that as well later. Finally, there's a more recent development of potentially high impact to the software industry. I call it the user foundations, where the users of software, banks, insurances, energy distributors, anyone who needs software for their main business, but where the main business isn't software, where they pool their resources and organize and sponsor and manage the development of the software they need. The software industry is large, but all the other industries needing software is of course much larger. So this is a recent but very important development that we will be looking at as well. Each of these models will get their own lecture later on. So then, in all of what I have described, we can find the innovations that open source software has given us. And I really count 4 areas of innovation. There's the legal innovation by way of licenses and accompanying processes, the process innovation of open collaboration processes, the not yet discussed software tool innovation, novel tools of engineering that open source has given us, and of course the business model innovation that became possible through open source, its licenses and its processes. Looking at this, I will simplify, probably not quite fairly, but for teaching purposes well enough, by allocating to each of these innovation a phase or originator. And the first would be this guy, Richard Stallman, a research scientist at MIT. He is the inventor of the GPL family of software licenses, free licenses, most notably GPL GNU Public License version 2, under which the Linux kernel has been licensed. These licenses are based or correlate with the essential 4 freedoms as he defined it for software to be that software should have, and software would only be free software if it fulfilled these 4 requirements, which I mentioned earlier: the ability to use, study, etc. The software free of charge. Richard Stallman also created or initiated with others the Free Software Foundation as the home of the licensees, a home for political action around free software, etc. So the underlying innovation that I attribute mostly to Stallman, who of course is a very innovative person, has done many things, but the most dominant one is the invention of the GPL license or the copyleft family of licenses. We will look at this in an upcoming lecture. This is also what you may have heard being called reciprocal or viral licenses that some companies shy away from. So Linus Torvalds is the original creator and leader of the Linux kernel, a software developer these days employed at the Linux Foundation, so that no company gets a particular hold over him. And the Linux Foundation is basically the steering mechanism now, in addition to Torvalds, of the Linux kernel, this operating system that is underlying so much of the software that we are using today. Torvalds didn't invent a license or anything, but if you will, by the way how he set up the Linux kernel development process, he invented or defined a new open collaboration process. With him at the top, he is the original benevolent dictator with his lieutenants who steers the development of the Linux kernel. But Torvalds is not the only one who, on their way of doing things or during their way of doing things, invented the open process. The other guys were the original team, or the other root of an open process, were the original people behind the Apache web server, a team of peers, of equal people. So there was no single benevolent dictator. These were peers, many handful of people who developed as equals the software that became the Apache web server, and they also created the Apache Software Foundation to find a legal home for the Apache web server, and then later lots and lots of other important open source projects. They defined the Apache way that I already mentioned, the principle, or emphasized or introduced the principle of meritocracy as a defining characteristic of the open software, open collaboration way of developing software. There's also the open source initiative, which is more of a legal home of the definition, which approves licenses, etc. So these guys jointly, maybe without wanting to, defined or created this innovation of an open collaboration process, which is defined in different ways depending on who you ask, but ultimately is this open collaboration process that I defined earlier or described earlier as an egalitarian, meritocratic, and self-organizing way of developing open source software. It varies in its nuances. Again, the Linux kernel has a fairly hierarchical structure, and Apache created this notion of a team, open team of equals. The Linux kernel is not the dominant model. If you ask me, the Apache model is the dominant model, but there are so many variations, which actually makes open source research so much fun. There might be some misconceptions since we are still in the beginning or at the beginning of this course. Two common misconceptions that people have on open source, and one is that if there's a project, it should be at your service. Of course, it's not at your service. So if you use open source software, if you want something about it, want to know something about it, you should be asking friendly for help rather than expecting that you must be given help. Similarly, within the project, if you're the leader, you can't command people. They are typically there on their own volition. working in the project because it's fun, and if you command them and they don't like it, they'll just leave. Here you can see a comparison between free and open source software, the emphasis on philosophy under free software and the emphasis on pragmatism and shipping software under open source software. These days, 20 years after the hard battles, these days they've mostly coexist in friendly ways. They all both have their own organizations, and it's all well established and legally cut and dry. All right, the third innovation in open source engineering innovation, tooling innovation is illustrated here. Open source software projects quickly realized that they have a marketing problem. They need to be found. Volunteers want to find projects. So the concept of Software Forge was created. Here you can see the mother of all forges, SourceForge in 2000. Today it's GitHub as the dominant Software Forge. It's a place where open source software development is happening, where you can find the projects that you're interested in. Basically, in addition to giving you good tooling, it's a matchmaking service for people wanting to contribute and projects looking for volunteers. So this is some of the innovation that came from open source. And finally, again, since I already touched on it, there has been a fair bit of business model innovation around open source, here captured by a saying, a quote from Martin Mickos, the CEO of MySQL, while it was still an independent company. Some people spend time to save money, some spend money to save time. That's why customers would pay for a commercial license and support services at MySQL, even though there was a freely available open source software version available. It leads to different models and project types, and I will revisit this later. That's it for now. Thank you very much for your attention, and we will continue in a bit.